So good morning everyone. Today I am going to deliver a lecture on photoelectric effect. So before starting the photoelectric effect, I want to make some introduction. See, all the matter that we see around us have dual nature, that is particle as well as wave. So when we are considering about the atoms, protons, neutrons, electrons, De Broglie was the one who pointed out that all the matter, all the particles, all the objects have dual nature, that is particle as well as wave. So he gave the De Broglie's equation, which indicates the wave nature of almost every object. The difference is the macroscopic objects or the objects which have a bigger mass have very less wave nature, so it is not visible. Okay. But when we say this, that everything has dual nature, when we talk about the microscopic objects like or subatomic particles like electrons, protons, neutrons, the dual nature becomes dominant, or in other words, we can say the wave nature becomes dominant. In the same way, if we talk about the radiation or the corpuscles of light, we can say it also has a dual nature because they are very tiny particles, so they can have they can have a particle as well as wave nature, and in the wave nature will be dominant. During the when we discuss about the dual nature of matter of electromagnetic radiation, wave nature was clear from diffraction, and all these phenomena which light undergo or any radiation may undergo. But there are only certain phenomena which tell us about the particle nature of radiation. So photoelectric effect was one of them which tells us about the particle nature of radiation. Okay. So what it was first of all I tell you it was discovered by Einstein. Okay. And this principle is has very much applications in practical life because it is used in solar cells. Cesium metal is used in solar cells, which is used to generate and store electricity. Okay, so it is a wide application. So what is photoelectric effect? It is the spontaneous generation of electrons when the light incidents on it. Okay. So if I say if this is a metal surface, not all the metal surface, only those atoms which have large atomic size like cesium. So in the big atoms, the outermost electron or the atoms which are larger size, the outermost electron is very loosely held from the nucleus. It is very easy to take out the electron because the attraction power with which it is bound to the nucleus is very less. Okay, and this electron can be taken out even with a slight quantity of energy. Okay, so how this demonstrates the particle nature? It is also we will see in this phenomena. Now, discussing about the definition part of photoelectric effect, we say for the atoms having larger atomic size, if the energy or radiation incident on the metal, the electron is spontaneously and at that time only generated without any time lag. The spontaneous generation of electron on the incidence of light is known as photoelectric effect. But this is only possible for certain elements which are having a larger atomic size. In this, there are certain things like, first of all, it is demonstrating the particle nature because if we are saying that the light of energy, quantum of energy, h mu is incidenting on the electron in the outermost shell and it is knocking it out of the atom. So a minimum amount of energy should be there in this quanta. Well, H is constant, is Planck's constant, having the value 6.16 × 10⁻34 joules second. So the only variable amount is mu. So the magnitude of h mu, which should be able to take out the electron, should be a good sizable magnitude. So there is always a certain frequency or certain mu which is required to take out the electron because h is always constant. And it is variable, which varies with different metals. For lithium it will be different, for cesium it will be different, for calcium it will be different, for rubidium it will be different. For all the elements have characteristic frequencies, or in technical words we can say threshold frequencies on which the electron emission takes place. And this can also act as a fingerprint of the element. There's a threshold frequency, very specific frequency, and if frequency is very specific, then we can say lambda or wavelength will be very specific on which the electrons comes out. So mu is equal to c1 lambda, c is the velocity of light, lambda is the wavelength. So if there is an existence of threshold frequency, there is an existence of threshold wavelength. Threshold frequency is the frequency on which the electron comes out. Okay, the minimum energy required for this quantum for the emission of the electron from the outermost orbit. So, if the threshold frequency exists, threshold wavelength will also exist. Okay, a threshold frequency we can denote by lambda. So, threshold wavelength will denote by. If the threshold frequency we are denoting by mu, threshold wavelength will denote by lambda. So we can say this one. C is the velocity of light, this is the threshold wavelength, lambda, and mu is the threshold frequency. Okay, so we are discussing that particle nature is shown by this photoelectric effect, and by this phenomenon we are confirming that the radiation has a particle nature, because if the radiation has particle nature, then only this quantum of energy is able to strike this electron and knock out of this. If this has a wave electron, then the electron, if the radiation has a wave nature, then the electron should come out at any wavelength. There is no such threshold wavelength is required or threshold frequency is required. So this proves the particle nature. Yes, there is an existence of threshold wavelength. So there is an existence of a quantum which hits and knock out the electron. So on the basis of this, Einstein gave an equation that the total energy of the quantum which incidents on the atom is equal to the work function as well as the kinetic energy of the electron. Now what is work function? Work function is the minimum energy required to take out the electron. So it directly indicates the force with which the electron is bound to the nucleus. Okay. So different elements have different work function. Actually, if we see work function denotes the macro size model of the energy with which the electron is bound to the nucleus. Because when we are saying the energy with which electron is bound to the nucleus, we are talking about a single atom or very micro level. But when we say about the macro level or the mole of substance or the grams of substance, so work function generally is talked about for the macro level of substance. Okay, but during the explanation part, if we say what is work function or what is there, so we will say it is the minimum energy required to take out the electron from the atom. Okay, so the incident photon is here. What it should do? It should take out the electron. Means it should cross the energy barrier or the attraction force with which the electron is bound to the nucleus. Plus, after taking out the electron, if the h mu has surplus energy after taking out the electron should come out with a sufficient kinetic energy as well. So, if there is surplus amount of energy in the h mu, it should cross the energy barrier, it should overcome the attraction force, work function that is, plus the electron should come out along with a certain kinetic energy. So if we say total energy equal to work function, we can denote by h mu plus half mv square kinetic energy. Okay, so m is the mass of electron, v is the velocity, h mu is the work function or the energy required, mu is the threshold frequency or the minimum frequency required for the photoelectric phenomenon to take place. For example, it might happen sometimes that for the blue color the electron is not coming out, but as we switch on the ultraviolet light, then the electrons come out. Okay, so blue was more than the threshold, so blue was less than the threshold frequency. Okay, so after crossing the threshold frequency only the electron emission takes place. They might ask you in the question that on a metal there are 4 red color lamps applied. Means the red light is thrown on them on the metal, then the electron is not coming out. So if two red lamps are more, put on the metal, reflected on the metal, should now there can be any effect on the emission of electron? Emission of electron, you will say no, because if the threshold is not crossed, no electron will come out of the atom. That is for sure. Okay. So what will happen here? There is a threshold existence after which only the electron will come out, because the magnitude of energy in the h mu is basically determined by threshold frequency. H is constant, and that should be sufficient to take out the electron. So if you plot a graph in this for this equation, and graph is between kinetic energy on the y-axis and the x-axis is frequency. So graph is basically looks like this. On certain initial frequencies, the electron emission does not take place, and after the frequency has crossed the threshold, then only the electron emission starts and the kinetic energy increases after crossing the threshold, if you are increasing the frequency. Okay, so in this formula, if you want to calculate the kinetic energy, so what we will say, h mu, this is the original equation. This is kinetic energy, this is threshold energy, this is total energy. So in this we can say kinetic energy is equal to h mu minus h mu. What we have done, we will kinetic energy on this side only. This we have taken this side. So we can also say like this. Okay. We can write c by lambda for this and c by lambda for this. Again, we can take c common. Okay, so we derive the last form of this Einstein's equation. Okay, so very simple numericals come out of it, in which they will be giving the threshold frequency and they will be asking the work function. In this equation, they will be giving the total energy and they will be asking the work function, because mass and the velocity of electron they will also be giving. Mass of electron we know, velocity they will be giving. Sometimes it might happen that they ask the kinetic energy, they are asking kinetic energy, and they are giving these two variables. So questions are generally very easy and easily answered. Okay, if you are increasing the frequency, after the threshold, the kinetic energy also increases for the electrons. Okay, and sometimes it might happen that they will tell you that this is the threshold frequency. If this is incident, this frequency incidents on the metal, then what will happen? See, if the frequency given is equal to threshold frequency, then the kinetic energy will be zero, and the electron will just come on the surface and will not move with zero kinetic energy. Okay, so in that the total energy will be equal to the work function, and kinetic energy will be zero in that case. If the threshold we are using, if the frequency we are using is the threshold. Okay, so thanks all. This was my lecture on photoelectric effect.